Just getting the everyone into the Hangout, and then we'll go live. Hey, just waiting on the star of the show.
I see. The planet of the show.
The planet of the show.
Yeah, the detail on that camera is much better.
Yeah, that's the nicest view that I've seen so far. The only problem is that Stuart has been knocking off his the cable off of his telescope.
Oh.
So, we'll just wait. So I apologize to anyone who's watching this, although nobody live is going to watch this, but when we have the recorded video on YouTube, you'll be seeing this, which is me and Phil just waiting for Stuart to show up, which we just saw him just a second ago. And I don't know where he went.
There we go.
Yeah.
But maybe fiddling with it.
Yeah, maybe he's fiddling with his telescope, yeah. But I thought that we would start with Jupiter. He doesn't have quite the fancy setup as some of the other people, right? So we can do Jupiter. The moon isn't up right now.
Right.
Uranus is kind of close to Jupiter, so should be visible by his telescope as at least a tiny little blue disk, right?
Let's see, given how big Jupiter was in the preview, yeah.
Yeah. I think
it should actually be, yeah, it should be not even that small.
That's
not as big as Jupiter, but...
That's what I was thinking, so I thought we'd try that. Definitely try M42. We're a little late. The Ring Nebula's gone down, which is in Lyra, which is actually off to the side, and it would be nice to see.
Right.
And Venus is way down. Well, not way down. It's just gone down, so it's off.
Let's see, he's an hour earlier. I'm fiddling with... We're on, right? We're taping?
We're taping, but we're not live.
Okay.
So
I've got my little software program here, and I'm looking to see what's going on in the sky.
Yeah.
And it's 8:35 where I am in Colorado, but he's an hour earlier in California.
Yeah.
So, Uranus is quite low.
Oh, is it now? Okay.
25 degrees above the horizon, maybe. So, pretty low. Might be too hard for him to spot.
There we go. Just turn that off.
There we go.
All right,
evening, guys.
Well, we got Gary. Gary's here.
I'm here. I'm not going to be able to do any scope tonight. I've got cloud cover.
Well, I thought we would just invite you as just one of the color commentary, and now people can kind of get to know your name and voice, and that way, and maybe even go out and Google at your telescope if you if you're up for it. We can give people a sneak preview of what your scope looks like anyway. I know you're overcast. I've been checking. Mike has got overcast guys. You've got a lot of background noise.
Yeah,
Why?
It's a bad connection, I think.
Yeah, it sounds like a bad connection there.
Am I giving you noise too again?
It's okay now. There, that's right there. Yeah.
Am I okay now?
Yep, you're okay. Yeah.
I think I got a bad connector on this headset. It's not an expensive one.
Yeah. But anyway, and I know you brought up some images last time we talked, and even like sort of the kinds of stuff you've been able to do. So we could even take a look at some of that as well and give people a sneak preview. Some of the stuff you showed me as well. So, yeah, if you're cool with that, either be part of the color commentary.
Okay.
Yeah.
Let me turn on a little more light in here. I look horrible.
Well, it's kind of cool to have. It kind of looks astronomy. It looks like you're hunched over a telescope.
Yeah, what is that?
I still look horrible, but at least the color should look good.
So Stuart said his internet crashed.
Oh.
Strange timing.
The whole internet, huh?
Yeah. Yeah, he destroyed the whole internet.
Some people have a talent.
Oh.
There you go.
I'm here.
Yay!
Sorry, I didn't see the little accept button.
Oh, okay, all right.
Yeah.
So are you ready to rock?
Let me just put it back on.
Okay. I can hear some mic sound from you, sort of breathing sounds from you, Gary. Oh, there we go. Okay.
Okay, you see it now?
Yep.
Okay.
You probably just want to pull your headset a little further away from your mouth. The little things we learn. Okay. Okay, good. Well, I'm going to broadcast.
I was going to say, I can't share anything because it's not public yet.
That's right. Yeah. So I will now. It's posting in 4, 3, 2, 1. All right. Okay. Hi, everybody. So Fraser Kane here. I'm the publisher of Universe Today, and I've got with me a team of astronomers who we've sort of organized to do some observing tonight. Now, as the way this always works, the sky tells us what we can and can't do, what we can and can't see. So it's not up to us. And so one of our astronomers, Stuart Forman is in San Francisco in the Bay Area, and so he's on Pacific time, and he's got a really nice view of Jupiter going on right now. The other person is Gary Gonella. Is that right, Gary? Yeah.
Yeah.
And he's got a gorgeous 14-inch Celestron telescope, but unfortunately he's totally clouded out. But I thought I'd sort of introduce you, and you can sort of bring him onto the show, and he can help provide some of the color commentary. And then, of course, my partner in crime, Dr. Phil Plait, is here to to join in our little star party. So once again, I'm going to switch to there. I'm going to switch to that view. So there's Jupiter. And so now what I'm hoping is that when I click on the view of Jupiter, everybody who's watching is seeing the view of Jupiter. And
did not happen here.
It didn't happen there?
I'm still seeing you.
It doesn't happen in the Hangout where we're sitting, but if you go into the stream, it should.
That's right, yeah.
I'm going to check that right now as soon as there we go.
Yeah. And so, but the thing was that they fixed a bug today, and by fixing that bug, it's possible that they, I guess, rebugged something else, some other nice.
I am seeing Jupiter.
Good. Okay. All right. Good.
How are you going into the stream?
Going to the Google Plus page.
Yeah.
Instead of just this Hangout where we have a separate window for us. If you go into the Google Plus main page and click on Fraser's Hangout where it says public, which is where everybody else will see it. And in fact, why don't I just tweet that? Which is where everybody else will see it.
Okay, that's the screen. All right, gotcha.
But now we're getting an echo from you, Phil.
Oh.
Okay, that's the screen. All right.
Right. So the problem with this is that you can only have you don't want the echo, right?
We're getting your echo too, Fraser.
I think it's coming from Gary or Stuart.
I'm going to put on some headphones just to because we don't want it to come on my speakers. Should have thought of that beforehand. Let me do that right now.
Okay, and I'm just tweeting this so we can get a few people coming in, taking a look.
Cool.
Give me a sec, you'll hear me clicking away here. We're live, looking at Jupiter on the G Plus Hangout Star Party. So we don't have a name for this yet.
Yeah, I'm calling it a virtual star party. That's my plan.
Okay, the VSP.
The VSP. All right. Good.
All right.
Okay, and then just to make sure that it's actually working, then we will tweet and do all that good stuff first, and then
it has been tweeted thusly.
Maybe I'll just retweet it then. I will
Assuming
retweet.
Right.
I will retweet your tweet.
Did I do it right? That's the question.
I don't know.
It's not Australia. There we go. Got it. People are saying they can see Jupiter.
Right on.
Any way to increase the size? Yes. Brian Dixon asks, any way to increase the size? Yes. Look closer at your monitor.
No, there's a way. Okay, so what you want to do, and take a second to do this right now, is you want to go to, there's a new extension that's been created called Better Hangouts on Air, and you can install that extension, and it will give you a bunch of options then. And one of the options is that you can open up in a wider view, and then you can even view the whole video in a full screen, and then you can click F11, and then that'll pop it to be full screen. So the extension is called Better Hangouts on Air, and I'm sure as I'm saying this, somebody is going to post a link to the extension, and someone else will probably post a link on just the raw video stream, so that you can just click on that, and then it'll pop open in full screen video. So. And
as always, if you are in the Google Plus Hangout, which you have to be if you're listening to this, unless you're listening to it on YouTube recorded, then don't bother. But if you're watching this live and you're signed up for Google Plus, please +1 this in Fraser's original stream post so that we can get an idea of how many people are here.
And so, you know, part of this is interactive. And so just to let you know, this is not our final presentation. The purpose of what we're really doing here is to just play around with different implementations, bringing in different telescopes, different astronomers, you know, just experimenting. And again, as I say always, the plan is that we have, I mean, I had 4 astronomers scheduled tonight, 3 are rained out, 1 broke his, and yeah, and one had beautiful seeing, some of the nicest seeing that he could have had. And so this is just the way it rolls. You know, sometimes we have everyone's lucky, and sometimes nobody's got good seeing. And so this is one of the this is just what's going to happen. So the only thing, Stuart, is we're only seeing the bottom half of Jupiter. So any way to bring that down? Yeah.
That's actually the top half. Oh, there we go.
Oh yeah.
Yeah, I think my camera's upside down.
Yeah. And then the other problem is we've got that mouse cursor. Is there any way to hide your mouse cursor?
Any way to, not that I know of, but maybe, do you guys know of a way to hide a mouse cursor?
Just move it to the side.
Yeah, I guess we're going to move it to the side, so yeah.
There we go. That's perfect for Jupiter.
Okay. Yeah. So it's fine right now?
Yeah, I mean, we can always try the other method we had before, right? We had the screen share earlier today, but I kind of like having the big Jupiter here.
Well, so. The other thing I can do is I can switch my Minicam so it's not just doing that one part of the screen, so it does the whole screen. You want me to try that?
Or the whole window, yeah.
You want me to try it?
Well, it's going to make a much smaller version. I kind of like this big Jupiter.
Yeah.
So
okay.
We'll figure this out. I apologize to people about that white arrow in the middle.
If anybody knows how to get rid of a cursor on a screen, make sure you let me know.
Yeah. If you just stop moving, will it disappear?
No.
No. Okay. All right.
Yeah.
That is a gorgeous shot of Jupiter for live.
Yeah.
It's pretty nice.
Isn't that amazing? Yeah. Yeah. This is absolutely. I mean, I know Mike is watching, and so Mike took the first few cracks at Jupiter, Mike Phillips, and I think this is. I'm hoping he's really appreciating this Jupiter. I mean, Mike's just had really awful seeing, and so this is sort of what you can see with a medium range scope. I mean, so what's your setup, Stuart?
So I have a what I have lined up right now. It's the scope is 140 millimeter apochromatic refractor from Telescope Engineering Corporation, and I have it's an f7. I have a 2x Barlow and an extension, and then it's going straight to the camera. So right now we're at 14. I'm streaming at 50 frames per second. And that's what I'm doing right now.
Okay, so Phil, can you unpack?
Relatively high. I'm sorry.
Right, and so Phil, can you unpack all that gibberish?
Let's see, 140 millimeters, 14 centimeters.
Yeah, so it's a refractor. So in other words, right, there's 2 major kinds of telescopes. There's the reflectors and the refractors. Reflectors are the ones that use a mirror for gathering the light and then focusing it, and that's, Newton was the person who originally came up with the concept of the Newtonian reflector. And those are often the big telescopes, and even the biggest telescopes in the world, the ones that Hubble is a reflector, and then the other way is the refractors, and they're the ones, like what you see in binoculars, where they use lenses to bend the light into a focal point. So I'll take that first part. Now, you said it's an f7, so what does that mean? Phil?
Me?
Yeah, f7?
The F number is the focal.
I barely understand.
The F number is the focal length of the telescope, and that basically tells you how far from the lens or the mirror the image comes to a focus. And it's a number that is a ratio of the diameter of the mirror or lens to how far it is. So f7 means the image comes to a focus 7 times the size of the lens. It's just that simple. He has a 140 millimeter lens. That's about 6 inches, roughly, a little bit bigger, I guess.
Yeah, it's about 5.5. Yeah.
5.5, okay.
Yeah.
So an f7 means it's coming to a focus 39, 40 inches farther away. So if this were a very simple setup, that's basically how long is that how long the telescope is? About a yard?
980 millimeters is the focus.
Okay, so yeah, about a yard.
Right.
That is what there are 2 terms we use to describe that sort of telescope. You can call one fast or you can call it slow. And when it's fast, that means that it collects light really well and you can see fainter objects. A slow one magnifies the image more, but it makes objects look fainter, so it's harder to see faint objects. In this case, f7 for a refractor is relatively fast, but because it's a lens, it magnifies the image a little bit more efficiently than a mirror does, and it's better for planets. Planets are bright, so they're easier to magnify a lot and see well. That's why when people always ask me, what kind of telescope should I get? I tell them that's like asking me, what kind of car should I get? I need a lot more information. Do you want to look at planets? You might want a small refractor. Do you want to look at things like the Orion Nebula or the Andromeda Galaxy, which are faint and big? Then you want a reflector. It just depends on what you've got, and it's very complicated. But this is clearly a really nice setup. A lot of detail.
So I think to use your car analogy, right? This is a sports car specifically for seeing planets. I mean, it really, to match that analogy together, I mean, this telescope is perfectly equipped to view these bright objects. And I was really hoping that Gary was going to have some clear views, because then we could compare and contrast what Gary's set up. So Gary's setup, as I said, is a 14-inch reflector, which is, a very, very big. It's the same size reflector that Mike was using the other night, except with Gary's, it's a Schmidt-Cassegrain. It's a short one, just like the Celestron's, the classic, those little stubby Celestron telescopes, but it's very big.
It's like a telescope that's folded up.
Yeah, it's like a telescope that's been folded up.
Instead of having a long tube, you have a mirror that reflects the light back, and then another mirror that reflects it again, and it's like an accordioned telescope, or one that's just folded up. So it makes it you can get a nice big telescope in a short, compact tube.
And you've done some other stuff to your telescope too, right, Gary? What have you done? You've also got it sort of set for specifically deep sky, right?
Yeah. I'm running at f2, so I'm 673 millimeter f2, and something that was mentioned the other night. My field of view is 87 by 67 arc minutes.
Wow,
that's amazing.
Yeah.
F2 is incredibly fast.
Yeah,
I am thrilled with the wide field. I've got a question for you, Stuart.
Yeah.
With your planetary work, have you tried any of the Lucky imaging stuff?
No, I don't know what that is.
Okay, I've been reading some about it, and a lot of the guys that are imaging planets, they'll capture several thousand frames, and they have software that goes through and picks the best and stacks them.
Oh, yeah, that I do. I didn't know that's what that was called. That's exactly how I do it.
Okay.
So what I will do is, when I actually image Jupiter, say, is I'll take a movie of it. And the movie will last about, usually don't want to go longer than 2 minutes because of the rotation, especially if you're imaging the Great Red Spot, because it'll move. Mm-hmm. And then there's a free software that you can get called Registax that will take the movie, and you can set it to stack however much you want to stack. The top 5%, the top 10%, the top 20%, and then within Registax, it has software in it that will sharpen, and it goes right in the right in the program, and it's a free program that's just available online.
Okay, yeah, I've never played with it, but I've done some reading on it, and some of the results I've seen are just spectacular.
Yeah, there's some really amazing astrophotographers. Mike Salway out of Australia. There's John Chumack, and both of them, a lot of their bread and butter is doing these really beautiful sort of planetary astrophotography. And this is what they do. They take a webcam. They replace their eyepiece with this webcam, and then they just run video of whatever the object is, and then afterwards they then look through the individual images and then pick the best ones, and then it'll stack them up for them, and you'll get this really nice combined image. And like I said, if you do a search for Mike Salway Jupiter or John Chumack Jupiter, the pictures are just phenomenal. You would swear you're looking at the Hubble Space Telescope, and they're not using a more complicated series of equipment than what than what Stuart's got right here. I mean, it's through the multiple frames. You're getting these, because you're getting all of this atmospheric distortion. You're just getting lots and lots of glimpses of the planet, and then you just stack them all up, and you get a really beautiful view.
Well, the nice thing about RegiStax is you actually don't have to go through each individual frame. It does some sort of integration software that it'll pick the best frames for you. You can go through them if you want, but going through 2,000 frames is a little tedious.
Yeah. Now, you mentioned earlier, one of the things we didn't sort of stop on was the fact that you've got a Barlow going.
Right.
And for those who don't know what a Barlow is, right, can you explain that?
Sure. Basically, it's a magnifier, and it goes right at the end of the telescope, and it magnifies everything by 2. That's the 2x that I have. I also have a 4x one that's in the garage that I mostly use for visual stuff. And what it does is it magnifies it, but because it magnifies it, what it does, it also cuts down the field of view, and it turns it from an f7 scope to, say, an f14 scope. And sometimes what you'll see with these planetary stuffs, if they have a really solid mount, is they'll go up to f28, which is with mine would be a 4x Barlow, and that gives you. It's very slow images, so you just do bright stuff, but you can get very, very close with them.
Yeah, and so I think this leads into one of the questions that we got, which is why can't we see the moons? And this is sort of one of the things that we've really discovered with all of the observing that we've done, is that the brightness of the planet washes out the brightness of the moon. So we'll be able to see the moons in a second, but we're going to need to do some wrangling. And so what happens is you get this. And so we have to pick. Either we're going to be able to see the brightness of the planet and not be able to see the moons. We'll be able to see fine detail on the planet, or we're going to be able to see the moons. So now, do you want to try bringing down the bringing up the brightness? Yeah, to see if you can see some of the moons.
1 sec. Yeah.
Yeah.
There's one of them peeking out on the right there a little bit once in a while.
That's Io.
Yeah.
Do you see it now?
Yeah. So there's Io, right?
There's Io.
And so if anyone's interested, I'm going to show you something, a piece of software while he's doing that called Stellarium, and this is just your absolute go-to piece of software. Let's see if this works.
I use it on my iPhone to look at the sky and figure out what I'm seeing.
Yes. So I don't know if actually I've probably still got it on you. So let me see if I can put it on me. Okay, there we go. So there's Stellarium, and it's a free piece of software. You can download it, and it is just absolutely the most wonderful piece of software for doing astronomy. You can change where you're seeing the sky from. You can change what time you're seeing the sky from. You can turn on the various constellations and all of that. So I've set this for San Francisco, so it's as if I'm in Stuart's backyard here, and so we can kind of see. So there's the horizon. There to the west, and right now Jupiter is right there. So, and I don't know if you can see the constellation lines around that, and there's Jupiter there. And what's really interesting, and we're going to try, we don't promise anything, there's a few things we're going to try and look at tonight. The first one is that Uranus is a little off to the side, but it's fairly low on the horizon, so we might be out of luck.
Yeah, it's going to be behind a tree for me.
Is it going to be behind a tree? Okay,
yeah.
Well then we'll we'll try a little earlier in the night. The other one we'll probably take a crack at is M31, which is also known as the Great Nebula in Andromeda. But because his telescope is more of a planetary telescope, it's not going to look as nice. And this is why I want a Gary scope, because, you know, Phil and I saw views of Andromeda just 3 nights ago that just you know, made our jaws drop. So when Gary gets online, then I think you'll see some really beautiful views. And then the other thing that we want to see, let's see if I can find it, is Orion. And there's a few things we want to see. So one, I know that was sort of made you vomit there. So we want to see the Great Nebula in Orion, and this is, you know, also known as a region called the Trapezium. And then I thought we'd see if we could take a look at Betelgeuse, which is this supergiant star, which is thought to go supernova within the next few million years. And it's just going to look like a bright red star, but at least you can say you saw Betelgeuse. There's a few other things we can look at too, but I think that's where we're going to start.
Okay, Fraser, remember what happened the last time I tried to move the scope. So
I know you disconnected yourself. Right. So the other entire possibility of this is that Stuart's going to disconnect himself from the internet, and we'll all just go home.
Yeah.
So, I don't guarantee anything. So could you try pulling out the Barlow then? Do you think, and see if we can see the moons a little more clearly?
Yeah, it'll take me a little bit to kind of pull it out and refocus it, but yeah, I can do that.
Sure. Yeah, because I think we've all. I mean, I don't know. Do people want to just leave Jupiter going for, an hour, and we can all just go about our business? I mean, we can also answer some questions here. So
you can see a nice storm, actually, I think, on it. It's not the Great Red Spot, or that actually just might be a dust bunny in my. Yeah, never mind. It's a dust bunny in my camera. Forget it.
I love those new discoveries.
Yeah.
Did you just discover a new storm or a new kind of dust bunny?
Yeah, it's a new dust bunny. Yeah.
But actually, and the other thing is those moons are actually pretty far away, so they're actually pretty stretched out, beside the planet.
Okay, well, let me know when you want me to pull out the Barlow.
There's a dark spot on the left,
yes,
just
I see
below. And that's moving with Jupiter, so I think that's on the planet.
Yes, I think that is a storm. I agree.
It almost looks like a shadow of a moon. What we're seeing here now, right, as Fraser mentioned earlier, the Earth's atmosphere is turbulent. It's moving around, and so that's distorting the image. And it's hard to see small, faint details on Jupiter. But Jupiter is an incredibly detailed planet, just like the Earth is. There are storms at all different scales. What you're seeing here, I mean, the disk of the planet is 86,000 miles across. It's huge. And it's dominated by these two dark regions that are basically storms that wrap around the planet. And we're seeing it upside down. The one that's thicker, that's on top, is actually the southern one, and the one on the bottom is the northern one. They're called belts. And on the northern belt, the one on the bottom, on the left, there's a dark spot. Mm-hmm. And it's, I don't know, about a quarter of the way into the middle. And it's just below the belt, and you can see it moving with the planet, which means it's really on the planet. It could be a dark storm. Jupiter has lots of dark storms. I don't think it's a shadow of a moon because there aren't any moons moving across the planet right now. If you look on the right, you can see Io. That's one of the moons of Jupiter. It's about the size of the Earth's moon, actually. And that is actually right now moving toward Jupiter. It's circling the planet every few days, and it's about to transit directly in front of Jupiter, and it'll cast a shadow as well then. But that's not going to be for about
3 hours, right?
No, it's actually about an hour and a half from now.
Oh, well, I don't know if we'll still be doing this in an hour and a half. Are you still there, Stuart? Have you got cut off? Yeah, I knew it. We lost him.
No.
Yeah, I thought we lost him. So, yeah.
I'm trying to sign on with a different account so I could show some of my photos if you want.
Sure, that'd be great. Well, you can always switch your camera. Remember what we did the other day. So you just don't have to. If you just switch your camera to
well, unfortunately, I've got two different machines. The camera's on my laptop, and that's how I'm talking to you right now. And my main machine's over here, and I can't run the software on it.
Yeah, you can absolutely sign in two different machines if you want. Yeah. Yeah, Stuart has, as I mentioned, Stuart has lost, has had a pretty flaky internet connection tonight, so he's probably trying to get back in right now. and I will re-invite him just to be safe.
There's a good question in the.
And Mike, I know you're watching. You should jump in if you want, and chat as well. Mike Phillips.
You know, I saw Zach Wiener left a comment too.
Did he?
Although he was insulting me.
Oh, okay.
Curse you, Zach Wiener, artist from Saturday Morning Breakfast Cereal, my favorite web comic.
Do you want to get him in here so you can yell at him?
Yeah. There's a good question here that asks, I've seen the 4 Galilean moons of Jupiter with a telescope. Is it possible to see any of the other of Jupiter's moons with a typical backyard telescope? The 4 moons, the 4 big moons of Jupiter are called the Galilean satellites because they were discovered by Galileo. And they're named Io, Europa, Callisto, and Ganymede. And they're big. Ganymede's bigger than Mercury. It's bigger than Titan, which is Saturn's biggest moon. And all 4 of those moons are pretty bright. They're about 5th magnitude. And what that means is they're bright enough to be seen with the naked eye. If Jupiter were black, you would actually see those 4 moons sort of in a line in the sky. You'd be able to see them, which would be awesome. But Jupiter's so bright, it washes them out. The other moons are much fainter, and because they're much smaller. Those are the 4 dominant moons. And I don't think you can see them unless you have a really big telescope. And you'd probably have to take pictures to see them. They weren't discovered until much later with bigger scopes than Galileo's.
Do you see me again?
Yep, we see you again.
Yep, we got Jupiter again.
My internet dropped off.
Yeah, like I said, we've been having that tonight. So then I think let's take a risk and let's pop out the Barlow.
Okay.
And then see if we can get it in focus again, and let's play around with going back and forth between seeing the planet and seeing the moons, and see if we can find some happy medium.
Okay.
And show people the Galilean moons.
All right. Hang on.
Oh, this is too cool, Fraser. James Grant Rex is saying, I'm currently bartending and playing this live at the bar, the Pilot House in Kingston, Ontario.
Hi, everybody.
Drinking in astronomy.
Drinking in astronomy.
In science.
And so just if you're trying to schedule your summer, the Venus is going to be doing its big transit back across the surface of the Sun. When is that? It's in June.
That's all I remember is it's June.
It's in June, yeah. June 5th and 6th, 2012. And it's going to be visible from the West Coast and the Pacific over to Asia. So it'll be visible from my house, barbecue at my house. I know people are going to take me up on that. Ding dong. But yeah, so west coast of Canada and the U.S., Hawaii, the Pacific, and all the way over to Japan and so on. So sorry, just to explain to people what I asked Stuart to do. So as I mentioned, that on the back of the telescope you've got that Barlow. I'm going to grab my my telescope. Hold on a second.
I should probably get a Barlow. I have a small telescope from Celestron that I've just got, and I'm starting to play with it. But it's been so flippin' cold out. When it's 20 degrees at noon, I'm not really in the mood to go outside and take my telescope to look at Venus. But I'm kind of waiting. Right now, Venus is up right after sunset, and it's really easy. It's the third brightest natural object in the sky after the sun and the moon. So if you go out after sunset, even when the sky is still relatively bright, and look to the west, you can see, I guess southwest actually, you can see Venus. But right now, it's coming around the sun, and as it comes around the sun and approaches that time in June that Fraser was talking about, when it actually passes directly in front of the face of the sun, which only happens every century, by the way. So this is it. This is your chance to see it.
You'll never see this again.
As it comes around, it changes phases just like the moon does. Right now, Venus is a little bit more than half full. As it swings around, it's going to get more and more of a crescent and get bigger because it's getting closer to us. This is the sun, and Venus is swinging around like this. It's going to get closer to us and get bigger and become a crescent, and it's really beautiful. So I keep thinking, I'll just wait. It's clear here all the time. I can wait for when it's not 4 degrees outside to take my scope out and look at Venus.
Yeah. So just to let people sort of know the difference, right? So I've got 2 little telescopes here with me. These are real telescopes. I know they're adorable. So this is what's called the Celestron First Scope, and one of these runs about $50, $40, and it's it's a fairly simple, fairly cheap construction, but it gives you a view of the night sky, and you would be able to see Jupiter, and you'd be able to see the rings of Saturn, and the moon looks fantastic. You can do some, mostly just bright stuff. You can see that Venus is a crescent, and this is a reflector. So same thing, right? So light goes in here, and then if we look right down the barrel of the gun, you can see that mirror down there, right? I don't know if I can.
Yeah, we got it. We can see it.
Yeah. So maybe I'll pull off this for a second. So you can see the mirror there, and so the light goes down the telescope, bounces off the mirror, comes back up, and then you can see this again. You can see this part in here where there's a mirror that bounces it upward, and then you get up at the top. You get where you focus, and you've got the eyepiece that you look in, right? And so one way that we're doing this with some of the astronomers is they're just bolting their camera right onto the eyepiece. And the other way that people are doing it is that they're pulling out the eyepiece, right? You can pull out this eyepiece, and then they're putting a special kind of camera that fits right into the and sort of replaces the eyepiece with their own view. So so that's kind of what we're doing. So this is one kind of telescope. And again, if people are looking for like a starter telescope, this is a good one from Celestron. Cheap. Like I said, you can get them for about $50, right? The other telescope that I have, and this is going to make Pamela happy, so this is called a Galileo scope. And so this was produced for the International Year of Astronomy about 3 years ago. And you buy this as a kit, and it doesn't come with a tripod. What it does is it comes with a mount, and then you can attach it to any any camera tripod, which is pretty neat. And so then once you do that, then it gives you a pretty good view. And we actually were streaming a view from a Galileo scope earlier today right into a Hangout, and it actually gave a pretty good view. It gave a view that's very similar to what you're seeing right now. So not as nice definitely as the bigger view, but again, this is a refractor, so this is kind of like a pirate, yar. You can look through the telescope. And these, again, are pretty cheap. I would say under $50 you can pick them up. And you have to put it together. So it's a great project for a kid.
It comes in a box.
Yeah,
like
you got
this.
one too. Yeah.
Yeah, I've got one put together, and I've got this one here. I've been meaning to donate it to my daughter's school for quite some time. I'll probably do that this semester now.
Yeah. And so those are two. We always recommend that people start with binoculars, but if you really want a telescope and you don't want to get too invested yet, start with one of these or that Celestron First Scope. Both of those are going to run you about $50, and it's like if you find yourself not wanting to pull them out and you see them collecting dust, then maybe astronomy isn't for you, right? But if you're bringing it out all the time and really enjoying it, then it's then you can upgrade to a nicer telescope. So how's it going, Stuart?
Okay, I'm there.
Okay, so we can definitely see Jupiter, and we can definitely see the bands on Jupiter. So can you sort
I'll
of...
change the gain. All right. So,
Oh, there we go.
Than I remember.
So can you... I'll put it
So-
sort of in the middle.
Yeah, so we can see Io, I think, but now it's flipped, right? Because the Barlow was flipping it again, right?
The camera got moved, and it's a sort of at a diagonal right now, and I figured instead of trying to... I had it in focus, and I didn't want to screw it up.
Well,
So-
there's a moon right at the bottom of the frame.
Right.
And you can see it blinking in and out. There it is.
There's two more moons right here.
Yeah.
There you go.
And so the problem with this, right, is we can't zoom. So we can't say, oh, can you zoom in and zoom in and magnify? But we can't do that. We can you only get what you get in the field of view, and you have to change telescopes depending on what you want to do. So
Right.
so Mike Phillips just jumped in. Hey, Mike.
Hey, Mike.
Hello.
Hi, Mike.
So Mike was the guy who was doing the observing for those the last 2 nights. So I think that's and
Yes.
he's getting rained on tonight, but I thought we'd at least bring in his brain.
It is needed rain, but I am enjoying the night sky kind of indirectly here, so that's nice.
So the other thing we wanted to do was Gary was going to give a bit of a preview. So he's got some of the images, and I'll try and sort of move to his window.
Yeah, let me.
Fraser, while you do that, would you like to see an image that I took of Jupiter stacking with Registack?
Oh yeah, that'd be great. Of course.
All right. So let me pull that up.
Okay, while they're doing that, those two moons that we saw there for a moment, oh, there they were again,
Oh, sorry.
are Europa and Ganymede. There you go. Europa's the one on top, Ganymede's the one on bottom. Europa is the one that's covered in ice and may have an underground ocean, may actually be, may have a very deep ocean under a thick shell of miles thick ice. And Ganymede is the biggest moon in the solar system, bigger than Mercury. It's huge, and it's mostly rock and ice as well. It looks brighter to me, actually.
Oh, Josh wanted to know what was the Celestron I was just showing you. So this is called a first scope. It's a Celestron first scope, and they actually made them for the International Year of Astronomy. So
I'm going out for a sec just to.
yeah, and it's sort of like, again, like very cheap, very inexpensive. If you want to give a person a first telescope, it's a good little refractor, and Celestron. Nobody ever got fired buying a Celestron.
I've been using them since I was a kid. It's a good company.
That's the scope you've got, right, Phil?
Yeah.
Yeah.
Okay, Fraser.
Oh, here we go.
Good.
Okay, cool.
So this image was taken last Tuesday. You can see the great red spot. Again, it's flipped up. No, it's actually right side up now.
Yeah.
And you can see two moons, and I can't remember what they are. The close one is Io. I can't remember what the other one is. And
That is gorgeous.
Thank you. And this is just taken. This is just taken with what you're seeing here, stacked in Registax, and it took me to do this processing about 20 minutes, so it didn't take long.
Those two
Wow.
dark storms there. That's phenomenal.
Yeah.
Yeah. Yeah, that's just amazing.
And actually, if you see the great red spot there, to the left of it are four of those, well, three, and then a smudgy one, white storms. And you can already see that they're looks like they're starting to move around the red spot. The red spot swirls around, and as storms pass it, they go above it or below it. It's really cool to watch that happen, watch the flow of the winds above and below it. And mind you, those white spots are as big as the Earth. Jupiter has 11 times the diameter of the planet you're sitting on right now. So there's a lot of real estate in this picture.
Who is it? Jason Maxwell has bought 5 of those Galileo scopes and gave them to the students as prizes. That's fantastic.
Nice.
Yeah, that's really great. And John Spooner asked, I've been blind recommending that first scope for people. Is it decent? It's decent for what it is. It's decent for a $50 3-inch telescope. So, you're going to see the moon, and you're going to see Jupiter, and you're going to see Venus, and you're going to see the rings of Saturn, and you're going to see some clusters, some open clusters. And if you're hungry for more, then you're going to want to upgrade to a bigger and better telescope.
Ooh, on Twitter, Kim Twister says, I'm watching too. I have an 8-inch Meade Schmidt Castigrain LX90. That's a nice scope. Contact Fraser if you have a webcam that you can hook up to it. Anybody listening, if you have a webcam that you can hook up to a telescope like this, contact Fraser. Email him, talk to him in Google+, whatever.
Yeah.
We're gathering telescopes. The
Yeah.
goal is to have, well, I guess 48 telescopes, right? One in each time zone
One in
and
each time zone.
hemisphere.
Right, but I mean, what you're seeing right now tonight is the team that we assembled for the broadcast. 2 of whom got rained out and clouded out. So unfortunately, Gary and Mike have terrible seeing, and but we've got. But at the same time, Stuart is making up for it. So yeah, if you have a telescope that you can somehow get images from the telescope into your computer, then we can help you sort of figure out the rest. The hard part is just getting the view into your computer. And so a lot of like the Celestron, they have like the Next Image system, which you can use. What are you using, Gary, for yours? You've got a pretty spiffy system to get your video in, or your image from your telescope into your computer.
On mine, you asked?
Yeah, yeah.
I've got a laptop out in the dome, and that's doing all the capturing, and then I'm using remote screen and keyboard into the house to run it. So I just fire the laptop up. And I've got a couple of things up that people might see.
Yeah, I just highlighted your image, so why don't you just tell what we're
Okay.
seeing?
what we're looking at right now, these are the latest images I've taken. It's a California nebula. This is the eastern end. And this is to show you what narrowband filters do. This one that's on the screen now is in hydrogen alpha. And then we also have sulfur 2. So here's a sulfur 2. And you can see how there's just a little bit there. And when I go to the oxygen, there's nothing.
And so what you're doing is you're viewing in sort of 3 different filters the same region of space.
Right. Looking at the same thing. So I'll shoot. This is about 20 minutes total shot time stacked together. And is that me humming?
No. Yeah, you're got that.
So the first one is I'll just shoot through the hydrogen alpha filter, which is 10 nanometers wide at that frequency. That's the light given off by hydrogen. What does it fill in the second level of excitation or something?
Oh, I think it's the 3 to 2. So if you take a hydrogen atom and you let the electron jump up to the 3rd level and it jumps down to the 2nd. So imagine walking up a flight of stairs and jumping from the 3rd step down to the 2nd. That's what's happening there. And it's when hydrogen is warm, it does that. And it emits light in the red part of the spectrum. So when you look at a gas cloud and use that kind of a filter, it picks that light out.
But you've got
really accentuates the hydrogen gas.
But you've got a stacked version of this, right? I mean, this is going somewhere, right, Gary? You've got some of your images that you've taken?
Yeah. Yeah, I can go over some of the stuff I've done. I just wanted to show that one.
Yeah, so this is pretty close to what we were seeing the other night. So, but we were seeing with Andromeda, for example, we could see the spiral structure of the galaxy. We could see the dust lanes. We could see satellite galaxies around Andromeda. So, you know, we're pretty sad that we weren't able to do it. But Gary's got such great seeing. Yeah.
Well, and go ahead.
Yeah, Gary, I was going to ask you, you're doing narrowband imaging, which is usually less subject to light pollution. And I was curious to the area of the country you're in. Do you have a lot of light pollution there?
I am in the LA basin.
Oh.
So
yes, then.
I'm a little ways out, but it's still a huge light dome. So when I shoot at home, narrowband is all I can do. The few times that I can get out to a dark location, I can get other things. But this is also, here's one more recent one that I just did that was done in the narrowband. Let me move it over there.
And so again, if people are watching this, we have no idea how many people are actually watching this. But if you can, if you can +1 this and just share it, and so other people can know that it's happening, that would really help us out.
It's been +1 119 times according to my stream here.
Yeah.
That's
so
really good.
if there's some people that are watching and not +1ing, then we need you to do your part. We feed on +1s. That's amazing. So what's this?
This is the Veil Nebula.
Wow.
And I've mapped the 3 different narrow bands. In this case, the hydrogen is green. And hydrogen's the most common. Is my screen moving around?
No, you're good.
No, I see it.
Okay. Hydrogen is the most common, so you're going to get the red. But I map it to the green because I like the way it looks. And then the blue is oxygen, and any red that's in there is the sulfur.
Well, and I'll just add that, in terms of what the real color is, a lot of it is just the interpretation of the person who is doing the photo processing. Because when you're looking at this, certainly through an eyepiece, it just looks kind of gray. So I've seen a lot of images of exactly the same thing that look completely different just because of different processing, and they're all pretty. And ultimately, it's all about taking pretty pictures.
Well, that's it. I'm not doing scientific work. I want things that look good. Now, this is the exact picture of the one before, where I've swapped the sulfur and the hydrogen. So in this case, the hydrogen is the red.
Yeah.
Now, I'll note that so the hydrogen tends to emit in red. It also emits in blue-green, but not as strongly. Oxygen is very strong in green. And there are other elements too. There's nitrogen and sulfur. Sulfur's red. Nitrogen emits in red. There's one flavor of oxygen emits in blue. It depends on the object. It depends on how hot it is and what filter's using, all that kind of stuff. The object here is to make pretty pictures, but in fact, when I was working on Hubble, I would do this as well. I would have these same sort of filters, and I would change what they would look like because your eye sees green differently than it sees red. It's better at seeing shades of green. So there were times I would do that because I wanted to accentuate something to see what it looked like. And it's great. Color pictures are not just pretty. Sometimes when you line up a red and a green picture, I remember when I was doing this, I couldn't get them to line up, and I realized it's because physically the hydrogen and the oxygen were in two different places. And so that's why they weren't lining up. And I wouldn't have been able to tell that if I hadn't actually taken the pictures, colored them, and stacked them up this way. So there's a legitimate scientific purpose to all this as well.
So Stuart, while we're filling time here, do you want to, because you're our only live telescope.
Yeah.
Now I see you're putting up some views. Did you take this?
Yeah, I took this. And I just wanted to point out that this is I have just basically a cheap Canon Rebel camera, and I took this with that Canon Rebel camera. It was about a 10-minute exposure, and stacked together, and just with CCD stack. And you can take some reasonably pretty pictures with some pretty low-cost stuff.
Yeah.
What's your light pollution out where you are?
It's not as bad as you, but it's still pretty bad. I'm in the Bay Area.
Yeah.
Okay.
And
Yeah. So, I mean, right now, again, all the people that we have right now are doing it from fairly light polluted skies. I mean,
right.
Again, hopefully the astronomers who've gone to like dark sky reserves will chime in at some point and let us know they're there.
Yeah, so I'm back live to my camera.
So this is live again, yeah. So now, did you want to try and find? People want to know why it's got that purple hue right now, but that's just in the software. Right?
Yeah.
Yeah, it's getting colored after the fact.
Yeah, I have the gain turned down. I can manipulate it to try to make it a little bit better, but
you can make it look natural again.
I could try.
Now, Gary, you're not getting you're using Minicam 2, right? Oh no, you're using the Webcam Max software, right? And you're not getting that arrow in the middle of your screen.
Oh yes.
Yeah.
I'm using webcam, and I've got dual monitors, so I've got it on the other monitor. So I've got my main one, where I'm picking the stuff up and then just sliding it over there.
Yeah. If somebody listening knows how to get rid of the mouse on the screen, again, I'd love to know.
Yeah, it might be a different software solution.
Yeah.
The Webcam Max, I think, costs $15, and the Minicam is free.
I don't mind.
Yeah.
Good $15.
Yeah.
Brian Gonigal wants to know how to +1 it. So up at the very top, underneath where you're seeing the video, it says +1, comment, share. And so you can +1 it, you can share it with other people who are in your circles, and yeah.
And you have to be signed up for Google Plus to do it.
Yeah, so I'm sure there's a lot of people who, because we've made this public, there's a lot of people that are watching who aren't signed up to Google Plus, and so aren't able to +1 it, and as well won't get notifications of when we do this. So
we have 171 +1s now.
There you go.
That's a lot.
That's a lot.
Hey Fraser, while I'm thinking about it, when is the Astronomy News Roundup tomorrow?
That's tomorrow at 10 a.m.
That's Pacific time.
Pacific time, my time.
So that's 1800 UTC.
Yeah. So let's see. So it's 10 a.m. Pacific time, 12 noon Central time, 1 p.m. Eastern time, and 1800 UTCs or GMT. So now over on Universe Today, I've actually got a countdown timer that shows the time to that. And so for anyone's wondering, that is the roundup we do with me, Phil, Pamela, Nicole, John Boise, Alan Boyle from MSNBC, I'm going to forget a million people, Emily Lakdawala from Planetary Society, and other sort of space journalists, and we're sort of going to round up the news that's happened in space and astronomy this week, which is sort of the opposite of what we do with Astronomy Cast, where we really pick one specific topic and just focus in on it like a laser beam and try to avoid news at all costs. So, cool. Okay, so then let's try and direct Stuart around a little more. So, Stuart, do you want to try going after something different now?
I can try M42 if you like.
You want to try M42?
Okay. It may be the end of the session, but I'll give it a try.
Right. I've warned people that in the past when we've tried to slew over to M42, or we've tried to go after Uranus, but when we went after Uranus, you knocked off all of the plugs and stuff off your laptop. You're kind of he's following his telescope around with a laptop as it's slewing around. So.
Okay, so I'm gonna go off for a bit, and you guys keep talking.
Sure. Yeah. So tell us once you've got M42 going.
Okay.
And so M42 is the great. It's the nebula in Orion, right?
Yeah. I've got another one up here.
Yeah, maybe we can
You
show
have a shot of it?
Well, let me see if I can. Let me try and do another screen share, and we'll sort of see here.
Okay.
So here's my stellarium.
Oh, I'm not seeing it. Oh, wait a minute.
Oh, but I haven't set it to me.
there you
Hold
go.
on a second here.
Yeah.
Let me try that, and then I will force me. Okay. So for those of you who haven't done it, and if you've got clear skies right now, if you look out, and if it's sort of night for you, if you look out to the southeast, Orion is the big constellation in the sky, and you probably recognize it's got the 3 stars that run across, and that's the belt, and you can see the shoulder of Orion, and you can see there's the 3 stars of the belt. It's one of the most recognizable constellations. And that bright star that's down below Orion is Sirius, which is the brightest star in the sky. And so then just below Orion's belt, and you can see if you've got dark skies where you are, you can see this with the unaided eye. Just below Orion's belt, there's, I guess it's called the scabbard. I'm trying to think what the other names are, but
The dagger.
The dagger, yeah. And so it looks like a sort of blurry spot that's hanging down right below Orion's belt, and in that is the Great Nebula in Orion, and it's also its designation is M42. And so that's what we're going to try and look at next.
This is one of the closest star-forming regions in the Milky Way galaxy. There are some that are closer, but this is the close big one. And if you were looking at our galaxy from another galaxy, like if you were in Andromeda looking at our galaxy, Orion would be one of the ones you'd notice. It's a big, bright object. It's about 1,500 light years away. And it's a couple of dozen light years across. And it's actively forming a lot of stars.
That's what we suspected, yeah, was that we would disconnect him from the internet. So we sent him on some kind of mission that he'll never come back from.
Well, I guess the Mayans were right.
That's right.
That's my new favorite hashtag on Twitter.
Yeah.
Whenever anything goes wrong, oh, the Mayans were right.
Yeah. Well, while you're waiting, everyone who's got dark skies, go outside right now. I guess your eyes will be all messed up, but you can actually see it. Kevin Blakely asks, how do I full screen this video feed? So to full screen the video feed, if you look further up somewhere, Dante Fernandez has put a link to the full page video, and so you can click on that, and it will pop open this video feed into a new window, and then you can F11 and make that full screen. But also, if you want to do this easier from now on out, you want to search for Better On Air Hangouts, which is a Chrome extension, and if you get that into your system, then you'll be able to, it gives you a bunch of little options that you can view it wider, you can pop it into a new screen, and you can even embed it onto another website if you want.
I'm writing that down.
Yeah, so it's Better Hangouts on Air, and what's hilarious was just before we were going to do one of these, I was sort of complaining about how difficult it was to convince everybody to do this, to be able to get this link, and then, and I forget his name, I'm so sorry, the guy who developed Better Hangouts on Air, he was like, oh, I'll make that for you, hold on, and then half an hour later, he's like, okay, your extension is ready. And so if you actually go and look at the extension, the screenshots are of Pamela on the sort of her talking while we're recording Astronomy Cast, which is pretty funny.
That works only for the Chrome browser, right?
That only works for Chrome, yeah.
Is there any other browser?
Well, you know what's really funny is that actually Safari is a lot more stable for running Hangouts. So yeah. Josh, you wanted to know what software? Right. So if anyone's wondering, that software that I was using to show you the night sky, that's called Stellarium, and it is totally free. And like when I get a new computer, I install Chrome and then Stellarium because it is just the most amazing piece of astronomy software out there, and it's free. It's just the best. Dan Rathburn wanted to know, will a motor on an equatorial mount work as well? I've got an old off-market with good optics, but it's pretty slow, so we need loan times to get good stuff. So I don't know, Dan, you may want to sort of give us some more information. Are you talking about getting your video into one of these hangouts, or just doing some observing on your own? Or for doing, like, astrophotography? Oh, I see, it's up higher. Yeah, I guess the question got answered. All right. Have we regained Stuart?
No, I'm here. I'm still working on trying to get the image.
Well, it's great to see you, though.
Yeah. Hi.
Mike, is that one of your pictures? I think we've lost. Is that one of your pictures,
No,
Mike?
it is. I had the microphone muted out. Can you hear me okay now?
Yep, I can hear you now.
Yeah. So I figured, as long as we're trying to share all the different things we have here, I thought I would cycle through some of mine. I'll probably put a link on my feed or whatever in the next.
Sure. Why don't you tell us what we're seeing?
So this is I'm a pack rat, right? So I keep all of my old images on a site called Multiply, and through the whole season I kind of group them all together. So I'm just kind of going through a slideshow of all this previous season. I was in the habit of getting up early in the morning to do my Jupiter observing. I give my scope a little more time to cool, and so I have a lot from the first half of the Jupiter season, and right now the season's starting to wane. Jupiter's starting to sink earlier and earlier into the dawn or the evening twilight. So I can't say I'm done with my Jupiter season yet, but I certainly have a pretty decent compilation so far, probably 20 or so odd images that were worth sharing, let's say. So I'll cycle it through again.
Why don't you tell us what we're seeing? So
early on in the season, Jupiter actually, in apparent size, is pretty small, and as Earth swings closer to Jupiter in near opposition, the apparent diameter of Jupiter actually will increase in size. So you'll see over the course of the season here that Jupiter will get larger and larger, and as the seeing conditions get better and it gets higher in the sky, you'll see better and better images here. Some of them are small because I resized them. Some of them are bigger because of better seeing. But it's interesting to see through the course of even just a single season how things will change. Right?
Now, is this with the 14-inch?
Yeah, this whole Jupiter season I did all the observing with the 14-inch and my Flea 3.
Right, and the Flea 3 is the camera that you've got attached to the 14-inch, right?
Correct.
Yeah.
Yes.
And that's the one that you were broadcasting into our hangout the other night.
Yes, and I actually do think that the aspect ratio that was being broadcast was off a little bit, so it did look a little stretched, kind of maybe biased in length versus width or something, but I've tooled around with that a little more to maybe get some better, crisper views next time.
But you've even got, like, the moons there. I mean, look at the Europa you've got there.
Yeah, so it's fun to look back on this stuff, too. You really get caught up in the moment a lot when you're doing observing and things. To be honest, I've said before in some of the previous broadcasts we've done, I got into astrophotography because I couldn't see with my eye what I could see online, which were photographs. And once you get into astrophotography, you almost forget to stop and take a look through the eyepiece once in a while. And so I've kind of kicked myself and pinched myself to force myself to do that, at least at the end of the session. And it's been kind of rewarding. So those that are getting into astrophotography, don't ever forget to take a look at the eyepiece, because you'll treasure those just as much or more than the photographs. Because your visual views don't always match up with the astrophotography views either. I think photography in general is a very interpretive thing, right?
So I'm working on getting Betelgeuse in focus here.
Okay. And then Gary, you've got, while we're showing pictures, what have you got there?
That's the Sculptor Galaxy. We have a star party out here that's the Riverside Telescope makers. They have the one up at Big Bear, and then in the end of October, they've got one called Nightfall that's out by Salton Sea. And gorgeous skies out there. This was the last time, last October, I got this, and this was taken with a red, green, and a blue filter.
That's really great.
So I'm real happy with the way that came out. This is what we're looking for here.
Yeah, it's not going to look like that.
That fit. Yeah, there we go.
That's just fantastic.
I always
Well,
like my green horse head.
Yeah, the horse head's a tough one to see optically, but so we've got a few more questions here. Remember, if you want to ask any questions, we've got we're looking through the chat, all of the comments that are posted under this Hangout, and so we'll sort of go through them and answer any questions. And again, if you're watching this, please plus one it, or and share it as well so people can see. Let's see. Question. Adam Alexander wants to know, what is the focal length and what effect does it have? I think we talked about that earlier in the Hangout, but essentially, the focal, that's the F ratio, right? So, does someone want to crack that? What is focal length and what effect does it have?
The bottom line is that the longer the focal length, the more you magnify the image. So the bigger that number is, the more you magnify. An f7 telescope will magnify an image more than f2. It's more complicated than that. For example, the smaller number lets you see fainter objects. So an f2 will be able to see the Orion Nebula better than an f7. But it also depends on the size of the telescope. There's all sorts of things that all play into each other, but that's sort of the overall gambit here. Bigger number, higher magnification; smaller number, fainter objects.
Excuse me, Fraser, if you want to click back over to me, this is how I focus the scope.
Mm-hmm.
And you can see it sort of looks like a diffraction grading there. Do you see that?
Yep.
Butterfly.
Yeah. So this is using, Mike, you'll have to help me on the pronunciation, Bahoknikov mask.
Oh, I was going to say
and,
Batinov?
Batinov,
both
yes,
right.
thank you.
I'm not sure.
Well, it's basically a diffraction grating that you put in front of the scope, and it's not exactly in focus. The center line should be exactly in between the two, but I don't want to push my luck right now. So what I'm looking right now is at Betelgeuse, and I'll take the diffraction grating off.
Stuart, thank you for that, because I've never actually seen a live Batinov, or however we say it, pattern. So that's actually quite interesting, and I'm glad you did point that out. I was going to make a mention of that too.
Yeah, so there's Betelgeuse.
Wow.
And, it's a little big. It shouldn't be that big, so it's probably a little out of focus, but you can see it's obviously red.
Yeah.
So this is not using that, the same reason Jupiter was magenta earlier.
There might be a little of that happening.
It may be a little of that too, yeah.
But Betelgeuse is one of those stars that you can actually resolve a disk from here on Earth. It's so big, but probably not with a telescope. I don't know.
Yeah, that's
not with a
I'm not
background
seeing the
telescope.
disc. I think I'm just a little out of focus.
You need some special techniques to be able to see Jupiter or Betelgeuse's disk.
Or have
There's some tricks you can do, but you need a big telescope.
Yeah.
So I had trouble resolving M42 just because the camera isn't fast enough. So I went over to Jupiter. Now that Jupiter is in reasonable focus, I'm going to try to get M42 one more time.
Okay.
Okay, I'll stay for that for another minute or two, but I do have to go.
Yeah, I think we're gonna, with the sort of scene that we're seeing right now, I think we'll stop torturing Stuart and wrap it up. Now, I don't know. I mean, would you be up for trying to take one more crack at Jupiter for people who joined us late? Okay.
Yeah.
Let me know if you can let me know in the comments if if I see a couple of votes for let's see Jupiter again, then we'll take a look at Jupiter again, and if not, then we'll kind of wrap things up. You don't have the moon up there yet, do you?
No.
No. Okay. Yeah.
Okay, let me know what you want me to do.
Quite late now.
Yeah, the moon is just up over the horizon, but it's not going to be visible from his.
No, I'm sort of in a little tree well.
So you're going to try that. Okay, let's go back and look at some more of Mike's pictures because these are great. When did you take these ones, Mike? Was these during the last opposition? Oh, if Mike's dead.
Yeah. Oh, there we go. You can hear me now?
Yeah.
There's a little delay in my unmuting for some reason or another. Yeah, this was taken with my 8-inch. I don't know if you can read this on the bottom here. I knew I was going to do an upgrade to a 14-inch Newtonian, and so I kind of preemptively bought a 5X PowerMate, and I was brave enough to stick it in my 8-inch. Now, my 8-inch had been treating me pretty well, so I felt comfortable with it, and I knew that I was going in that direction anyways. So with an 8-inch and some decent seeing, I was able to put the 5X PowerMate in to get about 11 meters worth of focal length out of some seeing on Mars, the last opposition. So I'm hoping I can do at least as good as this with the 14-inch, probably better, I'm hoping. So we'll see.
And so we get an opposition of Mars. When we say an opposition, that's when Mars is at the closest point in its orbit to Earth, where Earth and Mars are at their closest point. And so we see it at its largest point. And the last one was back in February 2010, and they happen about every 2 years. So the next opposition is actually going to be coming up pretty soon, right?
I think in March.
Yeah,
It's
yeah.
getting there. I think in the next couple of weeks it gets to about 10 arc seconds in diameter. So I got to start staying up late.
Yeah.
Once the rain moves out, right?
Yeah. And
So-
Mars is coming up sort of earlier and earlier every night now, and so
Right.
we
I've
should.
got it right on the horizon right now.
Yeah, and so if we keep this up, we'll be starting to see Mars as part of these parties. And so, part of what we have to just deal with is we just see whatever we can see. Whatever's up is what we look at with whatever
You know what we
telescopes
do?
we can use.
We should have a Mars viewing night when John Carter of Mars comes out.
Instead of the movie.
Yeah. I don't know, the movie, the trailer looked pretty cool. We'll have to
Yeah.
see. But it may just be a bash 'em up.
Yeah.
I don't know. But those pictures are phenomenal. I mean, you look at it, and you can clearly see the southern polar cap, the red hue of Mars, which is from rust. It's from iron oxide. It's dust on the surface. And that big feature sticking down that almost looks like Africa there is it's called Syrtis Major. And that's a big enough dark region on Mars that it was actually seen over a century ago. I mean, it was discovered a long time ago. I've only spotted it once, barely, through my telescope. I've never been able to get any close to this. This is amazing.
Yeah, that's phenomenal.
Sometimes I
Is
get lucky.
that white stripe across just above the polar cap, is that real?
So yeah, there was some times around this date here that it was real, but there's also artifacts along a lot of the limbs. So I really couldn't say for certain, but there was a point last opposition where part of the polar cap melting actually released some, I don't know the technical term for it. I'm not a meteorologist, although I should be because I'm rained out. Where it actually released a fair amount of carbon dioxide, yeah, and it actually turned into some sort of a cold front that actually moved through the southern latitudes headed towards the equator region.
Yep, Mars has weather. It's not like ours. And there's a term. I have to. Is it? Hang on a sec. I know. I wrote about it. There was an amazing picture that somebody took of Mars, and it was. Here it is. It's on my blog. I wrote about it a couple of years ago.
Now now Mike, your Flea camera, it's your Flea 3. It's full color, right?
No, it's not. And in fact, the camera that I had before this, which is the one I used, was the astronomy cameras, the image source, DMK 21AF04 that you see in the bottom here. I don't know if you can read it in the Hangout, but it was a monochrome camera as well. So I've been a monochrome guy since day one, really.
I have the color version of that camera.
Okay, yeah. Now I'm getting into this Hangout thing. I actually wish I had the color version, but it actually broke, and I haven't replaced it. So.
No. Yeah. So what Mike did is he took 3 pictures of Mars in 3 different filters and then added them together.
Yeah.
To make a quote unquote true color picture. And when you look at the 3 images there, you can see Mars looks really different because, in different colors it looks different.
Yeah.
The red part of it is not going to show as much in a blue filter.
Yeah, the blue actually shows the most clouds and kind of,
right.
I guess, moisture features, right? You can even see some here in these mid-latitudes here. Well, I don't know if the mouse cursor shows.
Yeah, I found what I was looking for. There are winds that blow over Mars, and when they go up, there are 3 huge volcanoes on Mars, and when the winds blow up, they condense basically, and it's called orographic clouds. We actually see them here in Boulder as the wind comes over the mountain. and they're very blue. And it's amazing that you can actually get pictures of these from the Earth with relatively small telescopes. It's cool.
Well, we've got a lot of call for Jupiter, so I don't know if you're up for taking a crack at it.
Sure. Just give me a couple minutes.
Sure. Yeah. No problem. Yeah.
And those Mars shots are gorgeous.
Yeah, I have some other ones that have some interesting clouds that Phil was describing, if I can find them here.
And then, Gary, you've got some of your images you're putting up, too.
Yeah, I just threw up the Rosette Nebula.
Yeah, that's a sensational picture.
Yeah, it is.
Thank you.
That's phenomenal. And so...
And that's...
the funny thing, this is a great example, right? Between Mike and Gary, they have the same, essentially, size telescope, but they're tricked out in two different ways. It's just a perfect counter to each other. Mike's telescope is really geared for more of the planetary stuff, the way he's got it set up, while Gary's telescope is really set up for the wide field, faint, deep sky objects like this nebula, like Andromeda, things like that. And the two telescopes it's just a great example of how you can take the same essentially size hole and use it for same size mirror and use it for two different purposes.
Gary, how did you get it down to f2?
It's I've got the Celestron 14-inch, and I've got the Fast Star assembly, so I'm at 670 millimeter f2. So the camera's mounted right at the corrector plate. And just real quick, this was such a learning curve for me, because when I first got into this, I put a camera, I had an 8-inch scope, I put a camera on it, went out to a star party and said, oh, I'm going to shoot the North American Nebula. And I got back a picture that just had some red in it. I had no comprehension of the size of these things out there. Shooting at f10 on my 8-inch scope, I was seeing about 5% of the North American Nebula. Even with my present, I don't have wide enough field to see it. I'd have to patch it together, which is another area that I'm attempting to teach myself how to do.
So in other words, you would take a bunch of images from one region and then take another set of images and then stitch the two together to create one bigger image.
Exactly. And the batch I was showing you earlier, the California Nebula, that's going to be my first attempt, but I've just been kind of lazy and haven't gotten to it.
Yeah. And so the other thing, while we're doing this, if you want to give us some feedback, part of the problem is that we sort of drop into just geeking out and nerding out over the images and the gear, and we'll try to explain it. But I think we're not creating anything very slick here, and that's sort of the point. We're just a bunch of buddies hanging out, looking at talking about telescopes and looking at some pictures, and I'd like to get more live telescopes. That was really the plan. So we're having to sort of look at people's pictures, which is sort of like a star party too, I think. But anyway, feedback, stuff you want to see, stuff you want us to do. I have no idea whether this is interesting to people or whether this is really boring to people. I'm sure the people who this is boring to have already logged off. But and hopefully we can get Stuart back with the image of Jupiter. That would be great to sort of Pat, to wrap this up. But anyway, if you want to give us some feedback and tell us what you like, what you don't like, more color commentary from Phil.
Bless. I actually have to go.
You got to run?
Yeah.
Okay.
I got to finish up some stuff here.
Cool. Okay. Well, I have no idea when we're going to do this again. The other thing I've been doing is, as I've been doing tests with people, I've been starting out just little hangouts, but not live hangouts. And so sometimes you'll see a hangout with me started up, and it'll say something like, telescope testing with Fraser. That's not a hangout on air live, it's just a regular hangout, but feel free to drop in and take a look at what we're looking at. In many cases, people are futzing around with software and technology, but sometimes you get some beautiful views of the sky. So if you want to drop in.
I think that's half the fun of it, Fraser, is just sharing experiences and seeing what other people are working on. And, that learning curve is the fun, I think.
I think so too. And I think to really take this hobby to the next level, astrophotography is the inevitable final step, and that's what turns this from you kind of look in the you look through the eyepiece and you see something and you think it's really great, but when you're actually then capturing those images and turning them into files, you can see that the stuff that Gary's doing. And so when we actually have Gary's live view, you'll see patchy colors of gray, but it's not the same as the final stacked multicolored versions that we see. So.
All right, one
I'm almost back.
Before I go. Oh, and there's Jupiter now. That figures.
Can you pull?
Can
you change the hue on that a bit so it's not so purple?
Uh-oh.
Did we lose him again?
Maybe it's frozen.
Oh no.
We'll give him a second to get back.
All right, I want to add. I'm going to probably do a live hangout this weekend. I don't know when. It might be on Sunday. But I'm thinking about starting up those sort of 1-hour live chat sessions where people can ask questions and just talk or whatever. So just a heads up for those of you who are in the room, because I know there are a lot of people who are watching this right now, so I thought I might as well say that. I'll have it on my my Google Plus page stream when I figure out when I'm going to do it, sometime this weekend.
Yeah.
Thanks, Phil. That's cool.
All right. I'm
All
out
right,
of here.
we'll see you later, Phil. Thanks.
Good night,
If you
Phil.
can hear me, thank you.
Thank you.
Hey, Gary, Mike, Fraser, see you guys later.
Good night.
Bye.
And again, we'll have this mixture of astronomers and then the actual telescope operators, and we can talk about what we're seeing and talk about science and yeah, no, it's good. So I don't know whether Stuart is going to try and come back. Let me just find out if he's planning to come back. If not, I think we'll wrap it up.
Yeah, I'm getting late here on the East Coast, so I'm probably gonna.
Okay, all right, and I think
Take one,
Gary's. I can hear your connection again, Gary. So I think.
Oh, is
yeah.
it getting noisy again?
Yeah, I can hear it. Yeah.
I'm gonna have to.
You guys need one of these little mics here that sits on the desks.
Yeah, absolutely.
I need a better one. This is the
Okay,
cheap headset.
back.
We'll figure it all out.
Okay, I'm back.
All right, and you're heading off to bed, Mike. So thanks for stopping by, Mike. And we'll, as always, just let me know when you got some good seeing, and we'll pop it into a hangout and make it a party.
Okay. Good night, Mike. Nice to meet you.
Good night.
Okay, and so Stuart, so that's great. So can you unpurple it?
I'll try. Please.
There we go. And there you go, everybody. So here's your sort of final view of Jupiter tonight.
Sorry. Okay, there we go.
That's good. No, it looks really good. And probably in a couple of hours, if we were feeling really ambitious, we would see the shadow of Io move across the face of Jupiter. But I think we'll try and queue up in the future. We'll try and sort of schedule things so that we get one of those nice transits of Io across the surface of Jupiter. And I think you can see a storm up in the upper left there.
Yeah.
And
I'm wondering if that might be Io starting to transit.
Is it? No.
Not yet.
Well, I'm not sure when the transit's happening, but cool. Okay. All right. Well, then I think that's we can sort of end on this view, and everyone can enjoy that beautiful view of Jupiter. And remember, this is totally live. This is what you would see looking through a telescope. And I think Stuart has crashed again, so I think I'm going to take that as a sign that it's time to wrap this up. Okay, well, thank you, everybody. Thanks to Stuart, thanks to Mike, thanks Gary, and thanks Phil for joining and helping to explain and showing your pictures and talking gear and tech. And thanks to everybody who's watching. I really appreciate the fact that you enjoyed this. And again, if the planets were aligned, I would have had 3 telescopes all going simultaneously for different views. But don't worry, this is how it works when you're an astronomer. You get what you get, and hopefully we'll be able to get a better view in the coming weeks and months. We've got big plans. And again, if you're an astronomer and you have a telescope and you want to contribute and want to participate, we'd love to have you. Just drop me an email at info@universetoday.com, and I will add you to the live stream, and you can join the Geek Out, and we can try and sort of teach some people about astronomy. All right. Well, thanks, everyone, and we'll see you next time.
Fraser, thanks for arranging it.
All right. Take care.